want to start off by introducing Dr. Eric Monson. He's a data visualization specialist with the Duke University Library Center for Data and Visualization Sciences. In this role, he teaches visual design and communication to scientists and helps humanists incorporate technology into their scholarship. And he has a PhD in physics and a background in collaborating with Duke faculty and students from math to computational biology to art history. That's pretty exciting. Eric has helped researchers transform, visualize, and understand their data. I will say he is a visualization master. So great person to learn from here.
Don't oversell.
I've seen the presentation. It's not oversell. Yeah, Eric's here to talk to us about effective data visualization. Thank you so much for taking the time in, and the floor is yours.
All right. Well, thanks everybody. Thanks for the introduction. Yeah, my name's Eric Monson. I work for a department in the library called the Center for Data and Visualization Sciences, and I help people from all over the university, in the med side, in the law school, the medical school, everything, trying to do better visual communication. And so that's what I want to talk to you about today is maybe get you thinking a little differently about how to mostly communicate your data. We'll talk about various aspects, but when you do that, what you'll hear coming through a lot in my talk is telling stories about your data, and I want you to be thinking about it that way as we go through. So let's start off with just a general definition. What is data visualization? And for me, it's very broad. Basically, anything that turns data sources into some sort of visual representation. And we usually think of charts and graphs and maps when we do that, but even a table is a visualization of data, so why don't we just use tables? This table of numbers was specially constructed by a statistician, Francis Anscombe. Maybe some of you have seen this before, but it's 4 sets of XY pairs. And in general, when we get some new data, especially if it's kind of too much to look at, it has a lot of rows, we might run some summary statistics on it. But that's what's special about this data set, is that the means of all the x's are the same. The means of all the y's are the same. The xy correlations are the same. Now we can stare at the numbers for a bit, and we will pick out some patterns. Like we might see, oh, in the second to last column, there's a lot of 8s. So some things pop out to our eyes. But the human visual system is just not great at taking in a bunch of numbers and sensing patterns in them. But when we use these numbers to offset marks along common axes right away, in a fraction of a second, our brains see that these 4 patterns are very different. Okay, so in the upper left, we've got what looks like noisy data around a line. So if we fit a line, that might be an appropriate analysis, or it might tell us something about the system we're looking at. But in the upper right, that's obviously not a linear relationship between X and Y. So, our software will let us fit that line, that's not a problem, but that's not necessarily appropriate or going to tell us something important. In the lower left, got what looks like really tight data around the line, and then this outlier. Okay, that may be a really interesting story we should investigate. In the lower right, if this data was, say, coming off a piece of equipment and we expected the data to be spread along X, and this is what we saw, something might be broken, okay? So data visualization can help us at many different stages in our research, from seeing what patterns are there, figuring out how we might want to analyze, to what I'll talk about more today, which is, you already know what patterns are in the data, and you just want to communicate them to an audience. But let's kind of start at a very basic point. When people ask me about visualization, they want to know what types of charts to use, kind of what's going to work well. Let's think about how we even build charts. What we tend to use when we build our visualizations is what we call pre-attentive visual attributes. Okay, things that to our eyes and brains pop out in a fraction of a second, like differences in orientation or line length. Now look at this line length. That already looks like a bar chart. Okay, we're starting to build visualizations out of these. Width, size, shape, differences in intensity or hue, spatial position is a really strong one for us. So these are going to be our building blocks, but we can't notice these really quickly if we start to mix too many of them together. Okay, so if we get a chart like this with lots of colors and shapes, it's just a mess. Our brains can't pick out any patterns in it. So what you see as a through line today is that I'm just going to take a couple of attributes. Like here, I'm using spatial position and then hue to pick out a certain pattern within that data and try to communicate it. Now, these different ways of encoding the data, they're not all the same in terms of our ability to quantitatively perceive the different patterns or the comparisons. Okay, so if we take an axis from like the least effective at the bottom to the most effective at the top, and we talk about, say, visualizations that are going to encode magnitude of some number, we can see that at the top, what we have is position along a common scale, lengths of lines that have a common baseline. We're really good at those. If we go down, there's things like area that we use off and on, and it's okay, but you have to know we're just not quite as good at quantitatively comparing areas. Same thing with color, luminance, or saturation. You know, we can perceive differences, but quantitatively, they're not as strong. Then if you get to categorical distinctions, we're really good at kind of spatial region that might be like clustering. We're okay at color hue, but some of the other things that we use like shape, not quite as good. And so what this leads us to in my general guidance is the classic charts that we see a lot that we're very used to. I think they're classic for a reason, and that's because we're really good at perceiving these sorts of comparisons. So at the top you see if we have categorical variables and some sort of number that we want to look at. Like here, I'm saying 3 different locations within the library and the average temperature throughout the year. A good place to start is a bar chart. You don't have to end up there, but a good place to start there because we can see even fine distinctions between those top 2 in length. If you have a date or a time and some sort of numbers you're looking at, a great place to start is a line chart. A line makes some sense because if we connect our data with lines, at least time exists between the data points. So, you know, a line might be a reasonable approximation of what's happening in between. With the bar chart, because of the way that we perceive comparisons, we kind of look at ratios of length. You really need to start at 0 with your bar charts, like here. But with the line charts and the scatter plots, you don't necessarily need to go to 0. So on the line plot, I can kind of zoom in a little bit on the data range. I might be able to put multiple different categories of lines on the same chart. If you have 2 numerical variables, and especially if you're thinking about what's the correlation between these things, a scatter plot is a perfect place to start. Partly because we actually can do fairly good quantitative perceptions of the amount of correlation between 2 variables by looking at how fuzzed out the data is or how much it kind of sits around the line. Okay? But the thing is, these are super easy. This is just like probably one quick story within each of these visualizations. Your data is going to be a little bit more complicated than that. And so whenever you present your data, you have to remember that there are multiple different stories that someone could kind of make up in their head as they're looking at it, multiple stories you could be telling with it. So those easy visualizations, this guy, Stephen Frankenary, I like the analogy that he uses, that the simple visualizations are kind of like reading a word. We can do that really quickly. When we read a paragraph, it takes a while no matter what, okay? And your visualizations for your work are going to be more like a paragraph, so you need to help your audience out, partly by making decisions and knowing what you want to communicate. So you need to make some decisions about which comparisons are the most important for your audience to perceive and in the story you're trying to tell. And so the way I'm going to illustrate this is by looking at a really simple data set. This is kind of inspired by a Nature Methods article where they just had 5 different items in 5 different categories. I'm trying to make it a little more concrete by saying maybe we have 5 different vegetables and the numbers, or maybe the number of people that said these vegetables are very green or yellow or cheap or tasty or gross. Okay? Very simple data set. A table actually works reasonably well here. Tables are super good for precisely communicating values. So in this cheapness column, we can see the fine distinctions really easily. So that's nice. The table's nice and compact. Tables are really good for lookup, especially if you have a lot of values. It's easy to find things. Okay? But we just talked about the fact that we're not great at seeing a lot of patterns just in numbers. So let's try keeping the same compact representation, but now instead of stating out the number, we represent the number by a rampant luminance of a color. Okay, we call this a heat map. It's very eye-catching. That's sometimes really important, making people notice your work. It's still really compact, like I said. What I tend to notice in heat maps is kind of blocks of light and dark. So I might notice this block of light under the green and the block of dark under yellow. We're not great at seeing fine distinctions in color, so all the cheapnesses look about the same. We also get kind of fooled by optical illusions of what other brightnesses or colors are nearby other blocks. So it's not great for those quantitative comparisons, but it works okay in a lot of situations. We can also keep kind of the same orientation, but represent the numbers by, say, the area of a square. Now, notice here that I have really strongly biased your perceptions of this data to the columns by my coloring. Okay, our brains take things that have the same properties and we group them together really strongly. And so here I tend to see these columns, and I can see some patterns here, like I can see like a ramp up and a ramp down in size. The cheapness all looks about the same, down, up, up, down. That comes across. It's just not great maybe quantitatively, but it gets the message across. Another area comparison that we often use is pie charts. Okay, pie charts are fine as long as you don't have too many slices. If you get lots of slices, it becomes really hard. We need to understand also that we're best at looking at slice sizes that start at 12 o'clock. Okay, so I could kind of go down these and look at the greens or look at the reds, and I have some kind of reference frame as to where those start at 12 o'clock. But we're not great at telling the distinction between sizes that are close to being the same. So at the top in the corn, comparing the blue and yellow is a little hard for us. Okay? There's another slight problem here, that the metaphor behind a pie is that these things are parts of a whole. And actually, the rows in our original data don't add up to the same amount. So Tableau that I used for these visualizations compensates by making the area of the pies different. You can see a little legend at the top. If those totals within each of the vegetables was one of my main messages or one of the main patterns I wanted people to see, I would maybe use a stacked bar chart. Okay, this shows these fine distinctions in the totals because they have a common baseline for the totals. I can kind of compare maybe the greens pretty well to each other also because those all have a common baseline. But this one is sort of like the pies, is really hard, say, comparing the blues and yellows, because they don't have a common baseline and they're pretty close in style. Okay, so if that sort of comparison, the properties within each of the vegetables was our important pattern that we wanted to see, I would maybe use what's called small multiples or a faceted bar chart, where each vegetable has its own bar chart. And you can see, it's a little hard to see here with the kind of gray reference lines disappear on this particular projector. But the blue and the yellow, you can actually tell some slight differences. I like this arrangement too, because even though it's a little harder, you can actually make some comparisons up and down as well. Okay, now contrast that with the more typical arrangement, which would be kind of grouped side by side bars. It's okay, but personally I have a lot more trouble with this kind of filtering out a color and sort of comparing all the blues or comparing all the yellows. It's fine within a vegetable. That's the easy one here. But you can't really go across very easily. And my eyes actually get kind of a little color strobing effect when I see all these colors next to each other. Okay, so I have a bit of a preference for this sort of arrangement in those bars. Another one that you might not think of, though, that would be kind of similar to this, having each vegetable have its own axis on a common numerical scale and just using a dot. So we call this a dot plot. Here, notice we can tell the fine distinctions between blue and yellow at the top in the corn. We can actually, it just happens, we can see the distinctions between the cheapness values as well. So that works out pretty well. The thing is, five different categories here is kind of a lot. There's sort of too many colors. Dot plots work great when you have just two different categories you're comparing, but this is a little tough. But in general, I like it. Now, we could cheat this a little bit, try to make it a little easier to perceive the patterns, kind of squish the aspect ratio so it's not so long, and maybe connect the dots with lines, and now it's a little easier to see, say, the patterns in the blues versus the yellows or the greens. That works okay, but you want to be a little careful connecting categories with lines. Okay, when we connect dates and times, that's fine, there's something in between, but like, I don't really know what's in between squash and Brussels sprouts. And sometimes people get kind of weird interpretations, like as you get more squash-like, you get more tasty. And you know, so you just want to be a little bit careful about that. Now, if the patterns within each of these categories was really what you wanted to convey to your audience, I might actually do the faceted or small multiples bar chart just the other direction than I did last time. This goes back more similar to when I was using the area of the squares, but now quantitatively I can make these comparisons much more easily. Sometimes what you care about is not all of the values, but kind of the distribution of the values. So in that case, I might actually use some sort of kind of like a dot plot, or you know, it's almost like a scatter plot with a categorical axis here. Just plot all the different values and see the distributions. There are more sophisticated plots like this these days where the circles will kind of pack instead of overlapping. You can do random jitter if there's a lot of them. But it's really easy to see here that like the cheapness is much tighter distribution than the other variables. Okay, that comes across. If we had a lot of values, we might go to something like a box and whiskers plot, something that summarizes the distribution rather than showing all of the individuals. So that was just a simple data set, but you see the message, I hope, comes through that it's you that needs to decide which of those comparisons is important for your audience to make and then design towards that goal. Now, in this section, I've got what I think is an important pieces of information here. It's just three very general tips that I think will kind of get you maybe 80% of the way there with your visualizations and your figures if you can keep them in mind. Okay? The first is to keep it simple. Now on the left, we have one of the default Excel pie charts. It happens to be a 3D chart. And the 3D nature does make it eye-catching. And as I said before, sometimes that's really important. But the principle behind a pie chart is that the area of the slices or the length of the arc is proportionate to the data values. And we can't help but see more orange here because of the 3D slab sticking out. Okay, so the 3D nature distorts the data, so just keep it simple. Use 2D charts. 3D bar charts are just as bad. Sometimes some bars obscure others. It's really hard to do lookup. Okay, so just stick with 2D. Second part of keep it simple, you might not notice at first, but it's this legend. Okay, whenever we have different colors for different categories, our software always makes a legend. And you know, in principle, that's fine. But as you're trying to explain something complicated to people, if they're saying, okay, yeah, yellow is tech and blue is service, wait, which blue is it? And then they're trying to compare sizes, that extra cognitive load on your audience makes them less able to hear your message and really absorb it, okay? So whenever you can, try to directly label your pie slices, your lines, all those things. It's not always possible to get rid of your legends. And unfortunately, your software isn't necessarily going to make it easy to do this all the time. And so I know it takes extra work, but I think it's really worth it to try to label things directly and make it more clear. Now, the third thing about keeping it simple is I kind of simplified the color scheme, and that goes into my second of the three principles. Don't waste color. Save color and use it to draw attention to the story you're trying to tell. Okay, so on the left, I've got a perfectly fine bar chart. It's current Duke employment by generation. I've got veterans, baby boomers, Gen X, and millennials. But the software colored all of the bars a different color. Now, the colors themselves are fine, but we just don't need color to tell the bars apart. You know, they're separated in space. They have a nice label underneath. So why not save color and use it to draw attention to the story, which here was the comparison between millennials and the rest of the generation. Okay, so the rest of the bars, I colored in a lighter, more neutral color. I used kind of a khaki color, but typically you would use light gray. Some people, for this reason, say that light gray is the most important color in data visualization. And we'll see it a little bit later, although it's going to be a little washed out by this projector. But you see this come up over and over again. So light neutral color, and then you punch the one that you want to talk about in a darker, more bold color. As long as you are providing enough context, as long as you're not distorting anything, making your story clear like this does not bias your audience in a way that is detrimental, okay? And that kind of goes into the third principle, which is every figure should have a purpose for being in your talk, on your poster, in your paper. And my assertion is that that purpose should not be just to show the data. Okay? Every figure should tell a story, or at least make an argument as part of a larger story. So on the left, I've got a perfectly fine line chart, Duke hires by month, January through December, in 6 different years. But the purpose of this figure wasn't so that people could tell 2012 versus 2013 and look at those values. It was to talk about this peak that happens in July. Okay? So I simplified the color scheme. I tried to change the title to make it clear that I've got multiple years there. And then I added annotations that weren't there by default. So this gray bar to draw people's eyes, and this text. Hires always peak in July, which is the start of Duke's fiscal year. Okay? So now people go into this figure, hopefully still with enough context, no distortion, but it's clear to them why I put the figure in and what they should be looking at. And then as long as I haven't screwed anything else up, they can decide how strong my arguments are, you know, whether I really have data to support that argument. All right, so there are quite a few kind of common missteps that people make, and it's mostly about kind of software defaults. So we have things like whenever we plot categories versus numbers, here I'm using a bar chart, what is the default ordering for the categories always going to be? Yeah, alphabetical. Okay, it's a very natural default. It's really good for lookup if there's a long list. You know, phone books, it's nice that they're in alphabetical order when we had those. But here, because of that alphabetical ordering, the values of the bars are kind of jumping up and down in a way that makes it really hard to see the patterns in the data. And all I have to do is sort the bars, usually descending according to their size, and now I get two different things out of it. One, it's much easier to see the comparisons and the distribution of the data, and two, I get a ranking, in this case, of the states and how many sales were made in those states. Okay, so I get that ranking. So think about this. I'm showing a really easy case, but actually this shows up in a lot of different data visualizations where you might just put, like some people will just put like a patient ID, and they'll always sort the data according to the patient ID, but the patient ID is just random or whatever, and so it doesn't help me see the data. Sort by something, okay? And try to think, every once in a while there's a really natural order to the categories and you don't want to screw that up. Okay, that happens. But there's a lot of cases where sorting by something really helps people enter into the patterns of the data much more quickly. The tables are often quite necessary to present organized information. but they're notorious at hiding patterns in information and data, okay? There's a few things we're going to want to do to this one. I just copied and pasted this out of someone's paper draft. On the left, the text in the left-hand column is what we call fully justified. So it's aligned on both the right and the left, and this is meant to make it look more clean, but actually what it ends up doing more often than not is introducing these big white gaps which are ugly and they make the text hard to read. Okay, so just left align your text almost all the time. Centering is fine once in a while, but if you have multiple lines of text, I think, even on a poster title, 2 lines of text, I think it's harder to read that because the next lines start at a different place. It's easier for us to read when we know where to put our eyes for the next line. The second thing that I see on this is all those grid lines. Now, our eyes are really sensitive to picking up high contrast horizontal and vertical lines. And, I understand why you want to separate the information, but the important pieces of information are actually inside the cells, not the divisions between the cells. Okay, so we want to de-emphasize those quite a bit. The third thing here is that the important values are in these last 2 columns, and not only are they not very visual, they also have some kind of visual noise here. After each value, you've got comma p equals and the p-value. Now, it's fine that the p-value is there. It provides some context for the statistical significance, but there's just a lot of visual stuff going on that's getting in the way of me seeing the data patterns. So I took this, I copied and pasted it into Excel, made a few changes, and it's not perfect, but I went from this to this, okay? First of all, left aligned all this text. Much easier to read now, okay? Second thing I did is kind of all over the place, I added what we call a visual hierarchy here. And if I can, usually what I want to do is make, say, 4 levels of hierarchy. Okay, the lowest level, the least important things, are things that I'm just going to throw away. Okay, like I threw away a lot of the grid lines because I just didn't need all of them. Okay, then maybe 3 levels of kind of brightness and darkness for emphasis. So even the grid lines that are left, it's hard to see on the projection, but the grid lines that are left are actually in gray rather than black. And some of these numbers, again, it's a little hard to see here, these numbers are actually in gray rather than black too, so they're still visible, but they're de-emphasized a bit. Then I have some text regular, and I put some in bold to kind of emphasize it and make that the top level of the hierarchy that people will notice first and kind of say, oh yeah, this is the most important, okay? I also made the patterns in the numbers visual, so I did in Excel what's called conditional formatting, where you can change a cell into a color for a heat map, you can change it into a bar. And so here you can see like the values for the African American females are all flat, whereas the white females are rising up here. That's much easier, but remember, tables are like any other type of figure. You can add annotations to tell people these are the significantly impacted residents in this particular data set. Okay? Helps people understand why they're seeing this table, and I'd say this is one of my biggest pet peeves is walking up to a poster that has a great big table in the middle. It's just this big sea of gray, and I don't know what the heck I'm supposed to be looking at here. Okay, so really try to help your audience out with things like this. Now, I said in my 3 principles that your figures shouldn't just be there to show all the data. And I wanted to show you this. Now, it's a little bit of a cheat. This is from quite a while back, but it's in New York Times data graphic. And the original splash page was actually just to show you all the data, okay? But you can tell that I don't care how many annotations I add to this, I'm not going to be able to tell stories with this big mess of lines. Okay, so the axes are actually jobs since the 2008 recession, either increased or decreased, and along X is different industries, either higher wage or lower wage industries. So this is a big mess. You can't really tell stories with it. So what they did is they realized we can't tell all of our stories with one figure. And this is something I want you to remember too, that you probably have a lot of messages you want to get across. You're not necessarily going to be able to do it all in one figure. Okay, so what they did is you scroll down, and then they left the axes the same. Again, it's hard on this projector, but you can see that all the data is actually still there. It's just some of it's been turned light gray. So now it's there for context, but then they left some of the lines colored and added more annotations to help explain the patterns here in the medical economy. And then in another figure, they can contrast that with something like the housing industry, which had a very different distribution. Okay? So really making design decisions that are geared towards telling the stories they want to tell. Now, color can be kind of tricky. There's a lot of different things we can go into. I'm going to show you a couple things that I really like. Lisa Charlotte Roth does blog posts for a tool called Data Wrapper, and I like how she presents her information. So these are a couple of her figures. Avoiding really pure or really bright and saturated colors is really important. So the pure colors is just like all of our software was originally programmed so that the red, green, blue values were really easy for the programmers. Okay, so we had red lines, green lines, blue lines, black lines, yellow, cyan. The problem there is that some of them are brighter than others, some of them disappear with the contrast. So these days, the defaults in software are typically quite a bit better. So the colors are different in hue, but they're kind of perceptually more similar. You want to avoid the really bright saturated colors, partly because it almost hurts to look at them. Okay? And it's an important principle that I try to tell people that if it's painful to look at your poster or your figure, nobody is going to sit there long enough to understand your story. Okay? So just stay with more desaturated colors, things that are easier to look at. Second part of colors that I'm going to talk about is when we have categorical colors. Say we have a set that we would call nominal. They don't have any particular order like people's names. There you want to choose different hues and brightnesses, which are just different from each other, and not use a ramp of color. A ramp of color for categories should really be safe for something that what you would call an ordinal set that has a natural ordering, like the days of the week or different years. Those I might give a ramp of color, but not apples, oranges, pears. The second part is something that I want you to keep in mind for kind of your overall paper or poster, that if you can, try to stick with the same colors for the same categories. And I know sometimes that's hard. You can't necessarily do it throughout a whole report, something like that. But you see a situation here where on the upper panel, UK is red, blue is China. Now when we go down, red is China and blue is Germany. As people are looking at your figures, you are having to teach them how to read them. If they go from one figure to the next and you're switching around colors, they have to kind of unlearn what you taught them in the earlier figures, and it just makes it slightly harder for them. Okay? So on the right, red is UK, blue is China. Underneath, blue is still China, but orange is Germany. Okay? It's just a little bit easier. And basically, like, all the stuff I'm telling you today is all just little changes. But they can add up to a big difference if you make a bunch of little changes. Colors also come up when we make heat maps, and there's different things I can talk about, but the one that I really want to point out, because it's unfortunately still common, is using a rainbow color map for mapping numbers into colors. Okay? You can see in these figures the data is just kind of smoothly varying. In MATLAB, the JET color map used to be the default. Now, luckily, it's Viridis or something like that. But there's two big problems. There's a bunch of problems, but I'll point out two with the rainbow color maps. One is we just don't have an intuitive ordering for, hopefully that's not going into the broadcast. We don't have an intuitive ordering for the colors. Okay, so we can memorize Roy G. Biv or something like that, but we don't have an intuitive ordering, whereas we do for brightnesses and darknesses. Those we kind of naturally put into order. The thing that I think is even worse is the fact that the rainbow makes your data look striped. okay? And the data is not striped, and I think that really changes people's interpretation of what they're seeing, that they see these stripes in the data. Now, if you're not doing data visualization, but you're doing things like design for your poster, trying to figure out colors for headers and titles and all that stuff, where I tend to go is to designers that know what they're doing with colors, because I don't, okay? Every school you go to, every company you work for these days will have style and branding guides, okay? And here, if you go to brand.duke.edu, they have logos, they have typography, they have images you can use, and they have a section for colors. And in that section, they have not only the main Duke blues, but they have what they call the extended palette. The top ones are nice bright colors that you can use for emphasis on things, and then the bottom part are much more muted colors that you can use for de-emphasized items, but all of these stick within the Duke branding. And frankly, for me, the nice thing is just reducing the number of colors that I have to choose from. You know, having an infinite color space is not good. Having some reduced set that's easy to pick from is easier. Text can also be a little tricky. Basically, you want to use minimal text so that people can absorb things more quickly and have it be very readable. So when you get things like, when you get, say, diagonal or vertical text on the bottoms of your bar chart, it's just slightly harder to read. We kind of want to turn our heads, and the diagonal is actually, it makes it kind of tough to tell which text goes with which label. Like some software will put which text goes with which bar. Some software will put the end of the text right under the bar. Some will actually center these long lines of text on the bar. And so if you have long labels, just turn your bar charts sideways. We're fine at reading the sideways horizontal bar charts, and the labels are so much easier. I know you guys wouldn't do this, but direct statistical model output does not tell any story. And I don't care how many annotations you add to this is not a story, okay? So you need to, it's hard sometimes, but you need to figure out ways to summarize and visualize your results that aren't just copying and pasting from your stat software. And then when you do the visualizations, it's super important, partly because the figures are one of the first things people are going to look at, that you want to make them as self-explanatory as possible. So really watch where you just use like column headers as the labels for things that are probably kind of abbreviated. I say use human readable labels. Now I know you are humans and you understand this, but you want to show this to other humans and have them understand. So watch your abbreviations, even jargon. You know, you're going to be communicating with people outside your field, and it doesn't take us getting very far outside of our specialties to where people aren't going to know all the details and all the abbreviations. Okay, so try to spell things out. And then watch even things like, you know, how many decimal places do you really need on this axis or on these numbers? Even if a digit is statistically significant, I would argue that that doesn't necessarily mean you have to put it on there. It's more about what distinctions should people really be making. 25% versus 36% is so much easier than 24.46% and 35.87%. Okay? And then if we have a title at the top of our figure, and you know, we tend to do this in posters. We put kind of little headers over our sections, but I actually like pushing people to put titles on almost all of their figures if they can get away with it. Because we read text top down, left to right in this society, and this text is big and bold, people are going to see this title first, and that can really be a help to them in knowing what the story is. So when you have that, try to use it to your advantage. So don't just describe what you're plotting, which here it says accuracy versus color and shape. Okay, I've got an accuracy axis, I've got color and shape, I'm comparing to a control. That's fine, but why not say accuracy improved by color, not by shape? Now people move into the figure knowing what the story is they're supposed to be getting out, and as long as I haven't distorted anything, they're going to get my message much more easily. Take one more minute to say Center for Data and Visualization Sciences. There's 7 of us that cover 5 different support areas. We help people find published data sources like census data. We cover some data science topics, not a lot of heavy like analysis, but we teach R and some Python and data cleaning and transformations. We have 2 specialists in mapping and geographic information systems. Those guys are really good with that. We have 2 specialists in data management who can help you all through the research life cycle, from when you're putting in a grant proposal and you need a data management plan, to how do you collaborate with data and files, how do you name your files, make sure you're doing backups, all the way to the end where you might need to share your data in special ways to comply with funder mandates, or make sure you get credit for the data that you're putting out there into the world. And then my specialty is data visualization. When I consult with people, like I talked about, I'll listen to their story, look at the data, help them brainstorm about what might be a good visual representation, maybe recommend tools, help troubleshoot problems. Often data is not kind of in the right form to be visualized or analyzed, so I help people clean in the structure. And then I do offer kind of design advice. I'll look at your figures or your posters or diagrams and help make them better. Give lots of workshops every semester. You can get on our mailing list. Our website is library.duke.edu/data, and there's a workshops tab. But we do also have videos of a lot of past workshops. So if you go to the online learning section, click on a topic, click on a title, and in the end, it's really easy to get a hold of us. If you ever have a question or want to know if we can help, we have this central email address, askdata, all one word, askdata@duke.edu. That comes to all of us, and depending on the question, we can decide who might be the best one to answer you.